Hi, Troy here from BJB. A couple months back, we received our Form 2 desktop SLA printer from Formlabs. Since then, we've been printing a bunch of really impressive, highly detailed parts. The obvious advantage to this printer is the accuracy and resolution you can achieve when compared to common FDM printers that many consumers are using these days. Luckily for us, the Form 2 makes parts that are so accurate and clean, they're perfect for making patterns for BJB's silicone mold making and urethane casting process. In this video tutorial, we're going to go through the process of printing an enclosure for a wireless electric skateboard controller, and as usual, show you many tips and tricks along the way. So join me as BJB continues to take the mystery out of materials.
First, we take our solid models into the preform software to prepare the files for printing. We orient the model and add supports before sending off to print. When printing is done, we remove the first part and we can now print the other half. The detail and precision of the part is outstanding. Next, we'll remove the part from the build plate and begin to thoroughly clean off any uncured residue by soaking in a bath of isopropyl alcohol. We need to be sure the surfaces are clean for priming and painting in later steps. We clean the part in 2 separate tanks for best results. To ensure the part is stable and increase toughness, we place it in a UV post-curing chamber to speed up the final cure of the SLA resin. It's time to remove the supports. Using clippers, we carefully remove the lattice support structure from our pattern. Next, we continue to clean up the pattern with sandpaper and an X-Acto knife. Wet sanding with 600 grit sandpaper smooths out any minor surface irregularities and removes any scratches from previous cleanup. This also provides us with an ideal surface for primer adhesion in the next step. We'll spray the pattern with BJB's SEM High Build Sandable Primer. We love using the SEM primer because it dries fast and sands beautifully without clogging up the sandpaper. Apply several even coats and allow it to dry. Another round of sanding to smooth the pattern and fine and repair any minor defects. This process may need to be repeated a few times, depending on the condition of the pattern. Once we're satisfied with the pattern, the outer surface of the patterns will be sprayed with BJB's SEM Clear Coat to add a high gloss finish, which will translate into our mold and cast parts. The inside surfaces of the pattern will not be seen, so no need to clear coat the other side. Once the clear coat is dry, we'll begin to set up our splitter board to divide the mold in 2 halves. Using a pencil, we trace the outline of the pattern in the chosen location, leaving enough room around the pattern for registration keys and sufficient mold flange. Small pockets are made with a rotary tool to allow the protruding tabs to insert and the pattern to lay flat against the board. We close any large openings with pieces of styrene cut and sanded to shape. Having these blocks stick out from the pattern creates a cleaner split line and adds an additional alignment feature for the 2-piece mold. Before we can attach the patterns to the splitter board, a few more holes need to be closed up. You can use tape or clay, but we use scraps of styrene lightly bonded to the underside to close the hole. Small drops of BJB's Instacure CA glue holds the styrene pieces in place. Once the holes are plugged, we can continue placing the pattern on the board, securing with small drops of CA glue. Because there are several through holes in our pattern we wish to copy in the cast parts, we'll use metal dowel pins in the mold construction and during part casting. We need to drill some shallow pockets to lower the dowel pin in a few spots. The pins will be held in place by the silicone, so locating them by depth is critical, so they go through to the other mold half. When the pins are in place, we can start to clay in any minor gaps around the pattern with BJB's non-drying plastilina modeling clay to ensure the liquid silicone mold material can't leak into any small cracks around the pattern. Next, we glue the acrylic registration bars around the mold flange to create superior alignment between the 2 mold halves. We then need to start making the walls of the mold box. Some 2-inch strips of smooth melamine are cut on the table saw. The strips are measured and marked for the desired length and then cut to size. The walls are secured in place with hot glue. The entire base is sealed to prevent silicone from leaking out. Note, we don't apply mold release to the surface because the mold silicone won't stick to these materials, and we don't want to ruin the shiny finish of our pattern with the natural texture from a spray release. The volume of the box is calculated. Using the TC5041 silicone datasheet, we can figure out how much silicone we'll need to fill the 2 mold boxes. Time to weigh out our TC5041 silicone. The A and B mixture are thoroughly mixed in an appropriately sized container, and then transferred to a new, clean container to eliminate the potential for unmixed streaks of silicone ending up in the mold. Continue mixing until you achieve a uniform color. Note the amount of space in the container above the liquid to allow for bubble expansion once we begin to vacuum degas the mixture. Once the mixture is placed in the vacuum chamber, it will rise up and the largest bubbles will burst. Then it will collapse, settle, and continue to de-air. It may take 5 minutes or more to effectively remove the vast majority of the bubbles, depending on the strength of your vacuum pump and the quantity of silicone mixed. Remove the container when ready. To minimize the chance of trapping air bubbles in the narrow details around the dowel pins, a small acid brush is used to slowly and carefully work silicone into the pockets. Once done, we can back pour the remainder of the mold box with our mold silicone. Fill both mold boxes to the top level and allow to cure for 6 to 8 hours. As mentioned in our other mold making videos, rubbing alcohol loosens the hot glue for easier removal. Leave the pattern and dowel pins alone and begin removing the acrylic registration bars, styrene blocks, and modeling clay. Any minor flashing can be sanded off with 800 to 1000 grit sandpaper. You'll see additional dowel pins are added to several one-sided holes in the pattern. We can then begin to add our acrylic vent dowels around the patterns. We're using standard size vents available from BJB's website and also some smaller 1/8 acrylic rods due to the tight arrangement of vents in certain areas. You can see the added complexity of vents needed in this geometry when compared to earlier mold making videos from BJB. The fill port is placed at a specific corner so that we can decrease the distance of material flow from the fill port to the opposite corners of the part. Now that the vents and fill port are on, it's time to apply our zip mold release in preparation of casting the second mold half. To ensure sufficient mold release coverage, we use an acid brush to reach in the deep channels of the registration keys. Not getting mold release in these areas would be a disaster when we try and separate the silicone mold halves later on. An even coat of zip release is then sprayed over all surfaces to ensure good coverage. More melamine wood is cut to make a taller set of walls to create the mold box. We use hot glue to hold the walls tight against the lower silicone mold half and glued to a baseboard for added stability. We can now mix and pour the TC5041 mold silicone. We pour very carefully around the pattern to distribute the silicone so it won't apply too much side pressure against the delicate vents and fill port. Fill to the top and allow to cure for 6 to 8 hours. Once the silicone is cured, we can begin removing the acrylic vents and fill ports. Next, we remove the walls of the mold box. Rubbing alcohol in a scraper helps make removal easier. Start prying the mold halves apart gently around the perimeter. Once the mold flange and registration keys are loosened, the two halves easily separate. Lightly flexing the mold, slowly remove the pattern, being mindful of the pins. Repeat the process for the other mold half. Remove the pins from the mold and pattern and place into a cup. For the molding process, we need to spray some E236 urethane mold release to ensure they don't stick to the cast urethane in the next process. Spray the silicone mold halves with E236 release to ensure parts release easily and mold life is increased. Note, E236 release is best for pre-pigmented parts and may cause bonding issues to cast parts that need to be painted. The dowel pins will need to be seated back into the mold halves in preparation for casting the parts. Close the mold halves carefully and gently. Our registration keys do a great job of aligning the tools, and the pins slide right into place. We'll make our pour funnels from rolling mylar sheets and taping them to hold their shape. The pointed end can be trimmed to the correct diameter, ensuring a secure fit. Now we can strap tape the molds to a baseboard to keep things stable. Wrap it tight, but not so much it distorts the silicone. We've added a small block of wood underneath to provide the desired angle for proper filling and venting. Filling from a low point and venting at the high points gives us the best chance at casting bubble-free parts. Now we can add our vent straws to the mold lid. We're using a combination of smaller and larger straws due to the pre-molded vent sizes used in the process. It's time to mix our casting polyurethane. Using BJB's Easy to Pigment TC879, we add some 6823 orange pigment and some 6824 primrose yellow to the B side to achieve a bright safety orange color. The pigment is pre-blended into the B side before adding the A. This way, we aren't trying to mix 4 components at once and run out of work time trying to get it all properly blended. Once the components are measured out, mix thoroughly with a mixing spatula, being sure to scrape the sides and bottom of the cup. To make sure no streaks of unmixed material end up in our parts, I use the double cup mix method and transfer to a new cup. Continue to mix for another 10 to 15 seconds. Now we can start to degas our mixture in the vacuum chamber to remove the bubbles created during mixing. You need to be sure there's enough vertical room in the container to allow the largest bubbles to rise and then settle, or you need to be ready to crack the valve to avoid a spillover in the vacuum chamber. After roughly 45 to 60 seconds, we stop the vacuum and prepare to pour the urethane. The material is carefully poured into the funnel, trying not to induce any air bubbles in the flow of material. The second mold's funnel is filled with polyurethane as well. The material flows through the cavities and begins to rise out of the vent risers, indicating we have a complete fill. Once the polyurethane is cured, we can begin to twist off the vent straws using pliers. The pointed tip of the vent risers makes removal easier and prevents damage to the part by creating a specific weak point off the actual part. The pour funnel tips easily twist off as well. Remove the strapping tape and begin carefully peeling the silicone mold halves apart around the flange area. Exposed dowel pins can also be removed to assist part removal from the mold. Lightly flexing the silicone mold loosens the cast part further and then demolds without too much effort. Repeat the process for the other mold, and there we have it, beautiful cast parts that need very little cleanup. And we can use our molds to make many castings for short to medium run production in demanding applications, like hurling down the road on an electric skateboard. If you crash, you might break, but the high-impact polyurethane should survive rather well. Thanks for watching. Be sure to check out other videos from BJB and subscribe to our channel to see the best mold making tutorials on YouTube.